So far, we learned about measure of center in our data. We learned about mean, median, and the mode. If your histogram or bars are connected together like this, then we learned that we call it a symmetric distribution. However, if the graph looks like this, it means that the majority of the data are located here, but toward the end on the right-hand side, you get less frequency. It means that your data is skewed to the right-hand side. The tail of the data is on the right, and you say that the data is skewed to the right-hand side. Now, we learned that if we have outliers on the left-hand side, or the tail of the data is on the left-hand side, we have the data that are skewed to the left. In general, the question is, if we change the distribution, then how variation has an effect on the data, and how do we analyze the data? We cannot just rely on the mean, mode, and median. For example, take a look at this data set. Here, mean and mode and median are the same, but how varied the data are. What's the measure of variability? The very first measure of variability that we're going to introduce is called the range of the data. The range of the data set is the difference between the maximum and minimum value in your collection. Well, range is maximum data entry minus the minimum data entry. Now, let's take a look at this example. We have two corporations, and as a statistician, you collected information about 10 enters that are hired. You have their salary listed below. In first corporation, the salary are $41,000, $38,000, $39,000, and so on. What is the range of the data? What is the range of the salary? You can list them from smallest to the largest and then find the difference between the maximum value and the minimum value, which is going to be $10,000. Now I expect you to ask, what about the middle data? They don't have any impact on our calculation. Well, we're going to introduce standard deviation that calculates all of the values in between. First, we're going to introduce what we call the deviation. The deviation of an entry like X in a population data set is the difference between the entry and the mean mu of the data set. The deviation is X minus the center of the data. If you have the population data, it's denoted by mu. If it's sample, it is X bar. Now, the population variance is equal to sigma squared, which is equal to the summation of X minus mu to the second power divided by n. N is the total number of data in your collection. And the symbol, Greek letter, sigma. The population standard deviation is the square root of the population variance. So the square root of the summation of X minus mu to the second divided by n is called the standard deviation of population. In this table, we summarized everything that you need about the formulas for variability. If you have a sample, the standard deviation is denoted by S, variance S squared, any data point X sub I, the average is denoted by X bar, N is the number of values in your collection, and the standard deviation is the square root of the summation of each deviation to the second power over n minus 1. And if you raise it to the second power, you get your variance. Now, for population, the symbols are sigma, sigma squared, X sub I, mu, which is representing the mean of the data, capital N, the number of data in your collection, sigma, which is the standard deviation of population, and sigma squared, which is the variance formula. Please note the difference between the denominator. The denominator of Standard deviation for sample is n minus 1, but the denominator for the population is just n itself. Question says, you have a sample office rental rates in dollars per square foot per year in Los Angeles. Question says, hey, find the mean of the data and the sample standard deviation. We have the following information. What are we going to do? We're going to go to our Jupyter notebook and use numpy.mean and numpy.std. Numpy.mean actually calculates the mean of the data, and numpy.std calculates the standard deviation of the data. And these two are the syntax for mean and standard deviation. As usual, we're going to import numpy as np. And remember that numpy library has an alias np. Well, we're going to list all these numerical values. We're going to create a list of lists. $69, $29, $46, and so on. Let's call this variable rental underscore rates. Now, you can convert the nested list to a NumPy array, as you remember, using np.array, open close parentheses, and just copy and paste the name of a variable here. In the next step, we're going to calculate the mean and standard deviation. Mean underscore rental underscore rate is np.mean, open close parentheses, just pass in the variable that you created here. The same for standard deviation. Standard deviation of rental rate is equal to np.std, and then pass in the rental underscore rates underscore array, and make sure you have one value less than the actual number of data in your collection, because it is a sample standard deviation. Now, if you print out the mean and standard deviation, you get the information as the mean, which is $30.96, and the sample standard deviation, which is $12.59. You can use our Jupyter notebook and practice a little bit and calculate the mean and standard deviation. But before doing that, I want to show you a shortcut. In this shortcut, we're going to use dataframe.describe. It creates all the information about descriptive statistics for us. How so? Well, if you just create a rental underscore rates, you can use pandas and basically convert that into a data frame. So rental underscore rates underscore data frame is equal to pd.dataframe, and then you just pass in this list. It creates a data frame for you. Now summary underscore statistics is equal to rental underscore rates underscore data frame, and now you can use dot describe, open close parentheses, describe method that just easily gives you all the information about your data set. It creates the mean, it counts the number of variables, the number of data, it calculates the standard deviation, what is the minimum value, what's the maximum value, and also counts the percentile easily for you. Now that we are in our Jupyter notebook, let us just import numpy as np, and then we're going to create a list of the data that are given to us. So rental underscore rates is a list of lists, including all of these values that we have. And then we're going to convert the nested list into numpy array. So let us begin, everybody. Why we are doing that? Because it helps to do the calculation, mathematical calculation, a little bit easier, a little bit faster. Okay, let me close up the parenthesis to avoid any error. Now let us calculate the mean. Mean underscore rental underscore rate is equal to np.mean. We're going to pass in the variable that we just defined here. And then if I just run this cell, calculate the mean, it easily calculates the mean for me. Let me add more cells. Now I'm going to calculate the standard deviation. And if I run the cell and then I'm going to take a look at the result here. As you can see, it's 12.58. So let me just erase this part and show you how it changes. You see, now it is the standard deviation for population, everybody. So make sure you add the necessary information so it knows that you are working with the sample instead of the population. Perfect. And again, if you want to use the shortcut, the describe, I'll just make sure I have enough cells so I don't have to go back up there. So as usual, import pandas as PD, and then create a list of lists. Here we go, and then convert that into data frame, pd.data frame, just pass in this variable. And then for summary statistic, you can basically just use describe method. And here we go. If I just want to take a look at the summary statistic, I have all the information that I need here. Count, mean, standard deviation, the minimum, the maximum, and also you have the first quartile, the second quartile, and the third quartile. The median is the 50th or MED, which is 27.50.